Right, this lesson we are looking at understanding the y-intercept. So if we remember that our linear equation looks like this, our y value relates to the y-axis. So this is our y-axis. Our x value relates to our x-axis. And our m, remember, is gradient, or how steep the slope is. And it's this bit we are looking at today, the plus c. Now the plus c is a number that's going to relate to a y-axis value, and that y-axis value will tell us exactly where the line runs into it. So what I mean is, if I had a line that went like this, then its y-intercept would be here. That's where it runs into the y-axis. If we had a line that ran like that, it's completely different. Right? This one has a positive gradient. It's a positive trend. This one has a negative gradient. It's a negative trend, but it runs into the y-axis down here. So this one has a negative y-intercept because it is below our Cartesian plane line of our x-axis, and this one has a positive y-intercept value. So there's lots of different things that we can do to find our y-intercept. Number one, what we can do is actually look at the graph, and that makes sense. If we have a graph, we can see where it runs into it. But if we don't have a graph and we just have our linear equation, what we can do is substitute the value of x equals 0. The reason I say x equals 0 is because if this is our x-axis and we can move back and forward on it, at x equals 0, which is here, smack bang in the middle, we haven't moved to the right, we haven't moved to the left, we have gone 0 places, and obviously that is where our y-axis sits. So it's important to know that at x equals 0, that's where our y-intercept is going to be. Right, so let's try that. Here's an example. I'm going to give you a couple of points. We've got 60 and 50, and this one is 20, 30, and we have a line that runs between them, and obviously the line will keep on going forever and ever. And in our last video we found that the gradient of this one is 0.5. So if I was trying to make a linear equation for this one, so far we've got y equals 0.5x plus c. Now we don't know what that plus c is, and that's what we're going to try to find today. Just move this up so we can see it all. Right, at this point, we've got some interesting ideas. So this is our x value and this is our y value. If we use our x and y values, what we can do is substitute in things that will give us where our c value is. So we know that our linear equation is y equals 0.5x plus c. This is the thing we're trying to find out. So that's the thing we're trying to get on its own on one side of the equation. Our y value, if we look over here, our y value is 30 this time. So 30 is going to equal 0.5 times our x value. And our x value, if we look over here, is 20. So half of 20. We're still trying to figure out plus c. That's still the thing we are looking for. Okay, we can do the maths now. So 30 equals 0.5 times 20, which is half of 20, which is 10, plus c. Still we're looking for this. Now we've got to keep this on its own and remove this. If this is a positive number, this 10, if on this side it's a positive and we want to move it to the other side, we have to change the operation it's working with. So this time, instead of being plus, it's going to be a subtraction. 30 take 10 is the same as our plus c. 30 take 10 we know is 20, so c is equal to 20. Now, number one, firstly we found out our c value, so we can say that our linear equation is now y equals 0.5x plus 20. So that's our final equation. But what that means, if we go back to our graph up here, when when this line runs into this axis here, our y-axis, it's going to be at positive 20. So this point on the graph, wherever it runs in, will be at 20. Now, it doesn't look right because we don't have a less scale in here, and obviously my graph is not particularly accurate, but I want you to understand that if we haven't moved anywhere right or we haven't moved anywhere left, we're still on 0, we've gone up 20, and that is our y-intercept. So we can do a couple of things. We can, number one, look at the graph. If we can see where the y-intercept is, it's nice and easy. Or the second thing we can do is substitute in for some values. If we have a point on the line, we can figure that out. All right?